Greeting engineers, welcome to another episode of Code Boulevard. We are going to talk about chaos engineering, what's the concept and why we should use that, and how we can build resilient systems and services. We will also check which type of tool and services we have in order to implement the chaos engineering in our systems. Let's just start with an example and see why we need chaos engineering. Imagine we have a system. In the top of this structure, we have a load balancer which sends requests to the web servers. We have hosted a customer front-end application and a web server. And all the requests from customer front-end will be sent to payment service. Behind that, we have a third-party API which is responsible to process our payment requests. Also, we have a cache service which interact with the cache replica and all the services located in availability zone A. In case payment service has some problem with communicating with a third-party API or cache service, we need to redirect the request to the availability zone B, which makes our system or service high available. And in case cache service is not available, we need to redirect request to the cache replica B. In this diagram, you can see this system architecture depicts a cloud-based environment designed for high availability in an e-commerce platform. Also, to enhance resilience, services strategically placed in different availability zones, which you can see in this picture. But the problem here, how we can be sure in case the zone A is not available, we can redirect our requests properly to the other zone. And here's the place that chaos engineering comes to the picture. And by systematically introducing controlled chaos through chaos engineering practices, teams can identify weaknesses, refine failure mechanisms, and continuously enhance the system's overall resilience and high availability. Now let's have a definition for chaos engineering. We can say is a discipline that involves intentionally injecting failures and disruptions into a system to test its resiliency and identify weaknesses. And the primary goal is to proactively discover potential vulnerabilities and points of failure before they manifest in the real-world scenarios. So, which is leading to system outages or other critical issues. Now let's check key principles and components of chaos engineering. The first component here is hypothesis formulation. Let's say in our example that we already checked together. In case the cache service is not available, we should redirect properly our request to another availability zone. So in that case, we will be able to keep our system up and running and provide a high availability system. The second one is experiment design. Plan and design controlled chaos experiments based on formulated hypotheses. It indicates that we can design experiment based on the requirement. In the diagram that we checked together, we expect the system redirect request to the other zone in case of failure in cache service. So we already know the experiment, how we should design it. And the next step is chaos injection. Actively introduce controlled chaos, failure, disruption, or any other type of failure into the system. In our example we can shut down our cache service in one zone and then see how the system is gonna respond to this failure. After we inject a failure into the system, we need to observe the system, monitor and log the behavior of the system during chaos experiments. After we collect the logs and monitor the system behavior, it's time to analyze the system. Analyze the data collected to understand how the system responds to chaos. So we already designed the experiment, then we inject the chaos into the system. We had some observation based on the log that we have collected. Now it's time to analyze the system behavior and see how it works under the chaos. Next step is gonna be identify weaknesses. Identify weaknesses, vulnerability, or areas of improvement in the system. It means in our example, if the cache service in case of failure doesn't redirect to the another zone, that's a problem and we need to fix it. And the last step is learning and iteration. Use insights gained to iterate on the system, infrastructure, or processes to enhance resilience. Now let's check the scope of chaos engineering. Chaos engineering is often associated with distributed systems, cloud infrastructure, and microservices architecture, where the complexity of interactions between different components can lead to subtle and hard to predict failure. By intentionally creating controlled chaos, teams can build more robust and reliable systems capable of withstanding real-world challenges. Now let's check chaos engineering practices in a real world. Netflix employs a chaos engineering tool called Chaos Monkey. This tool actually simulates the sudden failure of production instances by randomly terminating virtual machine instances in Netflix cloud infrastructure. By doing so, Chaos Monkey helps Netflix engineers identify weaknesses and vulnerabilities in their systems architecture and ensure that the overall platform remains resilient to unexpected failures. The second one is Azure Chaos Studio. Azure Chaos Studio is a fully managed chaos engineering experimentation platform for accelerating discovery of hard-to-find problems. So with the help of this tool, we can disrupt the applications or services intentionally to identify gaps and plan mitigations before the customers are impacted by a problem. And third one is AWS Chaos Engineering Service, which is part of broader offering called AWS Fault Injection Simulator. Here also we can check the AWS documentation about their chaos engineering platform that they have used. And here we have a good diagram that shows how we can design our experiment, how we should inject the failure and chaos into the system. Then we can observe the system behavior, and based on that logs and observation, we can analyze the system behavior. Same goes for Azure Chaos Studio. There are a bunch of documents here and videos you can check by yourself. And the last one is Chaos Monkey, which belongs to Netflix company, and you can find a bunch of examples on how you can implement the Chaos Monkey in your services. Here we tried to explain the concept of chaos engineering and how we can implement that in our system in order to build resilient systems. I'm Matt Gafuri from Code Boulevard. Thanks for watching.